Hello everyone. Today we are going to look at a Python script that can make your plotting of XRD data much easier. You can use this code to take your raw data file, for instance in CSV format, and turn that into a high quality graph that's ready for the presentation or a scientific publication. But all in just a few seconds. The code even labels the peaks of the XRD for you. First, we will walk through the code step by step so you know how it works. Then I will show you how easily you can change settings like the color, line thickness, or style of the peak labels to get the exactly look of the plot that you want. Okay, let's look at the code first. At the very top, we import two important tools. Number one, Pandas, and number two, Matplotlib library. Pandas basically helps us to read our data file, and Matplot actually does all the drawing and plotting. Right below that, you will see a list called Annotation peak. So here I have made a list of the peaks that appears in general for TiO2 annotation. This is just a checklist where we tell the code to check the standard positions and names of the peak to find them. You can easily change this list to list out for any materials you are studying. So next, the code loads your data and it uses try and accept block, which is just a safe way to open your file. So it tells the Python to try opening the file, and if it fails, it should just print an error message instead of crashing the whole program. So the code expects your file to have two columns. Number one, 2 theta, and then intensity. So you should have these two columns in your CSV file. If your file names these columns differently, you will just need to change these two words in the code to match your file. Next, we have the plot setting. So before we plot, we set the style, which means that we set the default font to Arial, make the graph axis lines like thicker, and put little tick mark on the inside of the plot, which is very common especially for XRD plot in the scientific papers. Then we have plt.subplots that creates the blank curves for our graph. We also set the fig size here to make it according to our requirement. For instance, here I have made it as 12 inches wide and 7 inches height. Next, we have plotting and annotation. This is the most important part. First, we have ax.plot that draws the actual line for your XRD data. Next, the code loops through that peak checklist we made earlier. So for each peak in our list, the code searches your data to find actual highest intensity peak, and then once it finds that point, the ax.annotate adds the label to the graph. So you can see we set the rotation of the text as 90 to make the text stands vertically. Finally, we clean up the graph. We add our X and Y labels. We also add a title, and we also use a line for the code to hide the numbers on the y-axis to have a cleaner look. We then lock the axis to show the range we care. For instance, here in this case, we have 20 to 80 degree, and we save the final picture as high quality PNG file with 300 dpi. You can change it according to your requirement. Now I will show you how can you customize your graph with practical running the code. You can also find this code on GitHub and the link is given over here.